When a memory card is completely damaged and its internal controller is burned out, the computer cannot read any data. At this point, chip-to-chip direct access technology is required. First, technicians scrape off the black epoxy resin casing. Underneath the casing are densely packed microscopic gold circuits. This step is the most dangerous. These circuits are thinner than a spider web. Next comes the spider board. This is the Russian-made PC3000 system. Under a microscope, technicians manually position microscopic mechanical probes. Each probe lands on a contact smaller than a grain of sand. There is no automation here. These probes completely bypass the failed controller. They connect directly to the memory chip itself. This tool forces access to the data deep within the memory chip. There is no file system. There is no firmware. The raw binary data is extracted piece by piece, slowly, through physical means. This is how data is recovered when a memory card is beyond repair.
This is absolutely the most formidable vehicle on our roads. Even the president has to stop for it. It's the yellow school bus. When a school bus stops and its stop sign illuminates, vehicles in all directions must stop immediately. All vehicles must maintain a safe distance from the school bus. Passing is only permitted after all students have boarded and alighted. Other vehicles may only proceed after the school bus has restarted. There are no exceptions. Violating this rule will have serious consequences. Huge fines, license suspension. In some cases, criminal charges may also be faced. Most school buses are also watching you. They are equipped with cameras and GPS systems. Violations are automatically recorded. School buses themselves are highly impact resistant. Their security standards are closer to armored vehicles than ordinary cars. All of this is to protect the children inside. This is why school buses have the highest right-of-way in the United States. This is truly an ingenious mechanical design. This washer looks ordinary, but it changes the way bolts are removed. When tightening, it functions the same as a regular washer. It distributes the stress. Nothing special. The difference lies in how it's removed. In heavy machinery, bolts endure continuous loads and vibrations. Over time, the threads can jam. The nut becomes almost impossible to loosen. This washer is designed for this situation. Turn the nut counterclockwise about 12 degrees. The internal mechanism begins to move. The locking component falls into a preset groove. This simple action releases the axial preload. With the preload gone, the friction also disappears. The nut instantly loosens. It can rotate freely, sometimes even by hand. That's why this washer doesn't prevent tightening. It simply prevents jamming.
Why don't most helicopters have ejection seats? This isn't a design flaw. Vertical ejection in helicopters is lethal. The rotor blades rotate directly above the cockpit. The pilot ejects and immediately slams into the blades. Therefore, most helicopters prioritize reinforced armor to improve flight safety. And ejection systems are completely unnecessary. But the Russian Ka-52 helicopter is different. In an emergency, the pilot detonates the rotor, instantly destroying the entire rotor assembly. Only in this way can the ejection seat be safely activated. At this point, it works similarly to a fighter jet. The pilot survives. The system is heavy. It's expensive. That's why almost no other helicopters use it. Russia is willing to bear the cost because the Ka-52 flies at extremely low altitudes. Low-altitude combat allows no room for error.
Most people throw away plastic bottles, but she turns them into cash. She collects bottles for free, old, flattened, forgotten. First, she peels off all the labels. If the bottle is dented, she carefully inflates it back to its original shape. Then she heats it. The plastic softens. She reshapes it for the next step. Then comes the really amazing part. She built a machine herself. This machine transforms waste plastic into strong yet flexible filaments. At first, no one believed her. Her family thought it was just another half-hearted hobby. Later, these filaments became products. Sturdy brushes, durable ropes, all made from recycled plastic. Word spread quickly. Orders poured in. Now she runs a business with 0 employees, 100% recycled materials, Profit margins exceed 90%. Her next goal is simple: to transform what the world considers trash into a million-dollar business empire.
Often hailed as the Ferrari of helicopters, not for its dazzling appearance, but because it's designed for those seeking the ultimate in comfort. This is the Airbus H145-D3. Its cost is approximately $10 million. The five-bladed rotor isn't for speed, but for smooth flight, less vibration, a near dreamlike flying experience. The cabin can accommodate up to 10 passengers, a more spacious interior, a quieter environment, allowing you to truly enjoy life on board, far exceeding most people's expectations of helicopter comfort. The nose is equipped with the advanced Helionics avionics system. A 4-axis autopilot provides precise control, less pilot intervention, a smoother flight experience. Such luxury lies in the fact that everything operates silently. You won't even notice it. So, would you buy an Airbus H145-D3 helicopter to fly? There's a reason for the exceptional skill of German bricklayers. It's not talent, but method. German bricklayers follow the same process. One brick, one layer of mortar. Each layer of mortar must be compacted. Each brick must be completely filled with mortar. Grouting is crucial. The mortar isn't just smeared on. It's compacted firmly or repeatedly added until the grout is completely filled. Washing with water is strictly prohibited. While this is faster, it weakens the mortar. Once the mortar dries, the grout becomes porous. This is why the wall starts to leak. This is also why stains appear on the wall later. There's another rule. Every wall is built along a baseline. Every brick must be laid strictly according to the baseline. This ensures the wall remains level from start to finish. Perfect bricklaying isn't magic. This requires self-discipline and repeated practice step by step. Did you know that helicopters can generate electrostatic discharge voltages reaching millions of volts? Therefore, soldiers always discharge static electricity by touching the fuselage with a metal rod before landing. When a helicopter is in flight, its rotating rotors rub against the air at high speed. This friction causes a large amount of static electricity to accumulate throughout the aircraft. While helicopters may seem harmless, they are actually heavily charged with static electricity. This poses a significant risk to ground crew, especially when landing fully loaded or hovering. Therefore, soldiers use a static discharge rod before touching the aircraft. One end contacts the helicopter. The other end is grounded. This allows the current to safely flow to the ground. The current does not connect to the person. Instead, it dissipates rapidly within seconds. Only after the charge has completely dissipated can a soldier safely handle equipment or cargo. Therefore, this metal rod is crucial. It determines the smoothness of the landing, otherwise, it could have very serious consequences.
You might not believe it, but these discarded plastic bottles are actually a major material in clothing. Most high-quality recycled plastic bottles are made into polyester fibers, commonly known as polyester fabric. First, workers collect and sort the discarded plastic bottles. Only clean, usable plastic bottles proceed to the next stage. These plastic bottles are crushed into small fragments. Then, these fragments are washed with hot water to remove dirt and bacteria. Next, these fragments are melted down to create tiny plastic pellets, which are then drawn into microfibers. These fibers eventually become polyester yarn. Afterward, they are sent to textile mills. There, they are woven, dyed, and processed. This is how plastic bottles become t-shirts, jackets, and sportswear. However, low-quality plastic cannot be spun into fibers. Instead, it is melted down and reshaped into plastic pipes, like the water pipes used in buildings. So, some clothes are not made of cotton. They are made from plastic bottles.
Why are the main cables of suspension bridges wrapped with extra steel wire? It's not for aesthetics. It's to prevent the bridge from collapsing. These massive main cables are not solid metal. They are made up of tens of thousands of thin steel wires bound together. They bear the entire weight of the bridge deck. But exposed steel will corrode over time. If corrosion spreads into the cables, it can cause serious structural damage. To prevent this, engineers tightly wrap the cables with high-strength galvanized steel wire, layer upon layer. This wrapping serves far more than just rust prevention. It keeps the cables perfectly round and stable, thus reducing vibrations from strong winds. This outer layer of steel wire is not just for decoration. It protects the bridge and maintains its stability, making the bridge safer and more durable for all those crossing it.
This is not insulating foam. These white cubes are called ceramic fiber modules. They can withstand temperatures of thousands of degrees Celsius. They look soft, but they are top-of-the-line heat-resistant materials. They can withstand temperatures of thousands of degrees Celsius. Installation is extremely simple. Align them with metal anchors, press, rotate, and lock. The ingenuity lies in the fact that these modules are subjected to intense machine compression before shipping. Once installed, simply cut the securing straps. The modules expand instantly. Then they expand outward, filling gaps and completely sealing the furnace walls. Zero heat leakage. The outer shell remains intact. Therefore, the factory can save significant amounts of energy. A soft outer layer, designed to withstand high temperatures. This is how factories control extreme temperatures, using smarter, not more laborious materials.
You might think of the Apache as just a flying tank, but in the eyes of engineers, the Apache is more like an armed supercomputer. Its internal structure is a massive electronic nervous system composed of over 16,000 intricate connectors. This is far more than simple wiring. It is the helicopter's brain. A loose connection, a faulty wire, could cause this multi-million-dollar aircraft to instantly lose control. It is this extreme precision that makes the Apache so exceptional. It powers the Longbow radar mounted on its roof. In just a few seconds, it can scan an area of 62 square kilometers, tracking multiple targets and locking onto threats from all directions. During the Gulf War, just 8 Apache helicopters, flying silently at low altitudes, destroyed an entire enemy early warning system. This is why the Apache cannot be mass-produced like a car. Each vehicle requires thousands of skilled technicians and takes nearly 3 months to assemble by hand. This little guy looks like a tiny potato. Place it on a spoon, and it'll jiggle like pudding. You'd never guess it's actually a macadamia hamster. Its thick tail isn't just cute. It stores fat and water like a built-in water tank. Macadamia hamsters are gentle and surprisingly affectionate. Hold it in your hand and stroke it gently. It will melt instantly. They're also incredibly clean. They have almost no odor, which is rare for small pets. As macadamia hamsters grow, they become round, fluffy little balls. When they smile, they look just like Pikachu. When they're hungry, they'll stare at you. Big eyes, completely stress-free, making you feel incredibly guilty. And what about after they've eaten? Completely enter shutdown mode. To be honest, it's not a pet. It's a mini stress reliever.
It seems a bit crazy. Why would they throw stacks of cash into water? In Pakistan, this is common. Their banknotes aren't ordinary paper. They're made of cotton fibers, so they don't fall apart when wet. There are 2 main reasons for washing cash. First, hygiene. Cash is one of the dirtiest things you handle every day. Washing cash helps slow the spread of bacteria. Second, counterfeit money. Counterfeit money is usually made with inferior ink. Once it gets wet, the color bleeds or fades, and the counterfeit money is immediately exposed. This is why Pakistani banks don't stop washing it. In fact, they support the practice. Some countries have even gone a step further using polymer banknotes. They're waterproof, washable, and virtually impossible to damage. Pakistan is also moving in this direction. So yes, it does seem strange, but sometimes the wisest habits are precisely those that seem wrong at first glance. What's the most valuable thing on a ship? Fresh water, of course, because the crew's lives depend on fresh water. Without fresh water, the crew would struggle to survive. A large ship consumes 10 to 20 tons of fresh water per day. Even with full tanks, it runs out quickly. Most ships produce fresh water by boiling seawater and condensing the steam. This leaves salt in the water. But over time, this salt doesn't disappear. It crystallizes and accumulates inside heat exchangers and plates like hardened plaque in an artery. Once scale forms, freshwater production drops rapidly. The crew has no choice but to start the heat exchangers. They flush the scaled parts with a controlled acidic cleaning solution. The cleaning solution creates bubbles and foam, dissolving the salt, thus performing a deep internal cleaning of the machinery. After a few hours, the scale is gone, and freshwater production returns to normal. This is why, on a ship, maintaining the desalination plant is indispensable. It determines the success or failure of the voyage.
This man couldn't afford bricks, so he built a house out of beer bottles. This was no joke. He collected thousands upon thousands of empty bottles, stacking them layer by layer, and then pouring concrete over them like bricks. Doors and windows, built using conventional methods, no cutting corners. Somehow, the walls were both sturdy and beautiful. The glass reflected light, giving the house a texture that bricks couldn't achieve. Even the floor was made of bottles. First, a layer of concrete was laid. Then the bottles were placed upside down on top and hammered flat. After cleaning, it became a crystal-clear, shimmering floor. He didn't just build one house, he built several. Each one was different in shape and style. When the wind blew, the bottles emitted a soft hum, and the whole house seemed to come alive. So the question is, would you live in a beer bottle house? How did the Black Hawk helicopter manage its flight missions on the Qinghai Tibet Plateau in China? What Chinese pilots awed wasn't its altitude capability, but its extreme robustness and durability. The Black Hawk followed a brutal rule. The aircraft can be damaged. The crew must survive. At 5,000 meters, most helicopters would quickly lose power. The air is thin, oxygen is scarce, and the engines shut down. But the Black Hawk wouldn't. Its two General Electric engines provided powerful thrust, even in low oxygen air, which is why it became the sole lifeline for remote border outposts at the time. Then there was its collision protection design. You can think of the Black Hawk as a giant shock absorber. If a collision was unavoidable, the landing gear would break first. The seats would shift downwards to absorb the impact. The fuselage would bend in a controlled manner, like an accordion. The helicopter wouldn't transfer all the impact to the pilot. Instead, it would sacrifice itself to absorb the shock. This is what true military engineering looks like.